So question 9 is about the electromagnetic spectrum, and it finishes with a pretty nasty 6 marker. So this question is about waves in the electromagnetic spectrum. So that's red, monkeys, insert, vultures, under, xylophones, great, long ones to short ones. The potential danger associated with the waves of the electromagnetic spectrum increases as well as frequency increases or as wavelength decreases. So what have we got? As frequency increases, B. Next one, microwave uses a frequency of 2.45 times gigahertz. So we've learned nunc, then our SI unit, kgmt, kmgt, and I taught you 10 to the 3, 10 to the 6, 10 to the 9. So we're going to need that. So times 10 to the power of 9. Make sure you're really good at that. Nump kmgt, and then this is in meters per second, so I can leave that alone. Calculate the wavelength. So we're going to need our foxes, stab wolves. We want the wavelength, S over F. There's F, there's S, there's S, there's F. So W equals speed divided by frequency. Then we're going to put our speed in. We can leave that alone, and then 2.45 times 10 to the power of 9. And that gives us our wavelength, 0.122. The microwave oven is 55% efficient. We're going to change that to 0.55 for our calculations. We're going to need our efficient, useful tools, and which is useful output over total input. Calculate the total amount of energy that must be supplied. So that's the total input. And we can see that's the output over the efficiency. So take the 42,000. For the useful output, divide by the 0.55 gives us 76,363 joules, and it doesn't ask us for significant figures, so we'll leave it as that. Right, now for a nasty 6 marker. So X-rays and radio waves are part of the electromagnetic spectrum. They're produced in different ways, so we're going to have to talk about that. X-rays are emitted when electrons with an atom go through changes. Okay, so fine. So what this is saying is I take the electron, it gets promoted to higher energy levels, and when it falls back down, it'll produce a photon of light. And that will, and the bigger the fall, the higher the frequency. So little fall, I might get a radio wave. Large fall, I might get a, I might get a gamma wave or an X-ray. So basic idea is that, and we'll talk about that in a bit more detail. Radio waves are produced by electrons in circuits. So again, we've said X-rays are promotion and fall back down. Radio waves are, I've got a wire and I'm going to take an electron, I'm going to wiggle it side to side. When I do that, it'll produce a radio wave, obviously a longer wavelength than that. So there's the basic ideas. And then we've got to refer to both types of radiation. So we've got to say, how are they similar? And then the next part, how are they different, and give some uses. Okay. So, next one, let's compare them then. X-rays have a higher frequency and a shorter wavelength. Radio waves have a low frequency and a long wavelength. 1 mark, I'm just saying that. And that's just using our red monkeys thing. Now we can talk about their energies for another mark. So X-rays have more energy than radio waves. We can say X-rays are ionizing, radio waves are non-ionizing. That's now 2 marks and a tricky 6 marker. Next part, now let's talk about radio waves. So radio waves are produced by vibrating or oscillating electrons in a circuit. That is, I need an alternating current. So an alternating current will generate radio waves. The frequency of the alternating current matches the frequency of the radio wave. So now we're 4 marks into a 6 marker. So that's, and I think all of that's quite nice. Next part, let's talk about their uses. So radio waves are used for communication, and the example I'm going to use is, for example, walkie-talkies. So that's radio waves talked about. Now we're going to talk about X-rays. So if electrons are bombarded at a metal surface, the metal's electrons absorb energy and get excited or promoted to higher energy levels. This part I've added in, but I'm just saying if I fire electrons at a metal, the electrons inside this metal get promoted and fall back down. I could have missed that in, but we've got this, it tells us what's happening, so I'm not going to get 2 new marks for that. So the next part is when the electrons fall back, this is where we get our marks. They emit different frequencies of light. A large fall will produce high energy X-rays. A really large fall will produce gamma rays tend to come out of the nucleus. So on to the next part. Now we've got a use. So X-rays are used to find broken bones, radiotherapy, airport security, and the basic idea is because they can transmit through low density materials and they're absorbed by high density ones. Now if I just quickly go back through that without all the fancy words, let's try and summarize it with very few words. So we're now just going to go X-rays have high frequency, low wavelength. Radio waves the opposite. X-rays are high energy and ionizing. Radio waves aren't. Radio waves are when we vibrate an electron forwards and backwards in an alternating current. The frequency of the alternating current will match the frequency of the radio wave. Look at those there. Next one, we use these for walkie-talkies. So there's 4 marks. Next part. X-rays. Well, we've got the part that goes through energy changes. So we're going to excite an electron, and when it falls back down, it's going to emit light. The bigger the fall, the more energy, or the higher the frequency. And then a use, they're used for finding broken bones because they're absorbed by dense materials and they transmit through low density ones. So that's it, using less words. I'll go back through all those words because this is a tricky 6 marker. It wasn't done particularly well nationally. They all just got into the habit of talking about electrons and just using the information that they were given into the question rather than answering the question well. So to go through that one last time, and it's going to make this video slightly longer than the others, but X-rays have high frequency and a short wavelength, radio waves the opposite. X-rays have more energy and ionizing, radio waves opposite. Radio waves are made by when we vibrate electrons in a circuit. The alternating current will match the frequency of the radio wave, and they're used for walkie-talkies. I'm going to miss that part out. Next part, we're going to excite some electrons, and when they fall back down, they're going to emit different frequencies. The larger the fall, the higher the energy. And they're used for broken bones because they're absorbed by high density and transmitted through low density. There you go. So that's a nasty 6 marker.